Hello grade 12, welcome to yet another video. And well, a good Samaritan, Katlejo, sent me this question paper in full. So I extend my gratitude to you, Katlejo. You've really helped a lot because other kids really needed this full paper, and all thanks to you for assisting with the paper. So I'm just going to do the two questions that were missing in the previous video. So I will link this video to that one as well as that one to this one in the description. So we're not going to go through all the others because we have solved them already. So we're missing question 4. So we're going to start with question 4. Okay. So question 4 is still analytical geometry, usually one that involves circles. It's always there. It's always there. So please do not be cowed by this thing. It's always there. Okay. Now we are told here in the diagram the equation of the circle centered at N. Okay. We can see there that there is a center N has this equation. Okay, they're giving us the coordinates of that center, but they're also giving us that equation. So this one is in the extended form. So for us, we need to solve this by completing the square so that we can make a lot of sense into it. So here, when you complete the square, you will take what is under the square root. You come here and say, look, the coefficient of x, you half it and then you add it because you take the original sign. So you're going to half that. So half of 24 is going to be 12. Then we square that and then we go on and say y, because y is alone. And then again we go to the coefficient of y. It's minus 10. So this would have been a y minus 10. So the answer here should be negative, right? And then half of 10 is 5 squared equals. And then we're going to take those squares. So we're going to take 12 squared plus, remember we added these initially, so it's going to be plus 5 squared, which is 25. Maybe let's just show it like this. And then when we transpose the 153, okay, so a lot of things got cut. So maske situilungisa kancane. So here this is going to be squared, and then we're going to take 12 squared plus minus 5 squared. Then we transpose the minus 153, which will give us what would be the radius. Let me just get my calculator. I'm not too sure if I remember very well. This gets a bit complicated, but all I know is that it's 144 plus plus 25. Hi. Hey, asingaqhelani mina ndazi kwenzeke ntoni ke pha. Khona into ezicofekile, so seyifuna ungixelela izitori le nto. Anyway, so that should be 16. Okay. Let's double check. 12 squared plus 25 minus, yeah, that's 169. So 169 minus 153 is 16. So this is the useful way in which you want to write that equation. And remember, guys, don't need a second invitation. As soon as you see something, please get to work. Don't wait, because you're going to give yourself a steep hill for no reason. Then the next question says the equation of the circle centered at M is, so there is our equation. So this one is already put in standard form. so that we can learn a lot. So already we can tell that the coordinates of M is going to be -6 is to -3. So we always take the opposite values there. Okay, so they are actually indirectly giving us the center M. Okay, P and S are tangents. Okay, to the circle centered at M, at S and R respectively. Okay, now once we are given points of tangency, what is the story? We know that, look, the tangent is always perpendicular to the tangent is always perpendicular to the radius. Hey, it doesn't look like it's doing the things, man. Come on, Anasun Pape. Okay, it looks more like it. But again, this is a construction of our own, so we're going to break it up a bit. Okay, so so what do we know? We know that the tangent is always perpendicular to radius. The same will apply there because these are tangents. Okay, the other thing that we know, tangents from the same point to the same circle, they are equal in length. Okay, there's a theorem that says that. Okay, so we can see we're doing a lot here. Now we're told here also that PR is parallel to the x-axis. So if PR is parallel to the x-axis, what does this mean? This already indicates to you and I that this line should also be parallel to the y-axis, because any line that is perpendicular to the x-axis is effectively parallel to the y-axis. And what does that tell us? Since this is perpendicular and that is parallel, it already tells us that the x, since that is a vertical line, the x coordinate at M is the same as the x coordinate at R, which is -6. What about the y coordinate? Now that is a bit of a tricky one. All we know is that we need to find the radius. The radius is the square root of 5, so this is 5 units. So now from -3, we're moving 5 units down. This becomes -8. Okay? So be very quick. Do not waste time, because if you work your magic, I'm telling you, you're going to succeed. And then we're also told that K, which is that point over there, coordinates -17 is to -5, okay, is a point on PS. That's all right. Now the straight line joining N and M cuts the smaller circle at T, K, and the larger circle at S. Okay, not a problem. Now we are finished. So what can we do with all of this? You can already see we've already done some justice to our cause here, so we'll just flow from here. Now what we can do is that, look, since we've got 2 points N and M, we can determine the gradient there. But since this line is perpendicular to PS, the inverse of that gradient, or a reciprocal if you will be the gradient of PS. Knowing that we've got a point on PS, which is point K, we can substitute that and get the equation of of line PS. All right, great. That's number one. Number two, we know that, look, if the radius here is, so MS as well, is going to be 5 units, right? As well. Okay, great. Because those are radii or radii, so they should be equal. Okay, so there's a lot of detail that you can add to your diagram to make it easy for you to work out a lot of situations. Now fine, what we can do, we will notice the one thing that, look, since we've got 2 points, we can actually find the equation of that line as well. Not a problem. And essentially the equation of MR is defined by the x coordinate, which is 6. So it's going to be x is equal to 6. It's a vertical line. The gradient is undefined. Well, the gradient of that, the equation of PR is going to be essentially equal to minus 8 because it's a horizontal line. The gradient is 0. Right. Is there more that we can say? Well, we can see that, look at P, the coordinate of y is going to be minus 8, right? Because it's at the same level. It's a horizontal line. But the issue is that we don't know the x coordinate. That's what we may want to work out. But since we could work out the equation of PS, we simply substitute minus 8 in that equation. It will give us the x coordinate. Okay, great. So there's a lot of things we can do, but again, you don't want to overly interpret your diagram. You just want to get to work. So let's go. 4.1 says write down. See? Write down the coordinates of m. We've already sorted it. So we know that m is going to be minus 6 is to minus 3. Easy stuff. So you get your 2 marks. So it's essentially the opposite of what is inside those brackets in that equation. So 4.2 says calculate. So here you cannot just show up with an answer. We need to see a calculation. The length of the radius of the smaller circle. Okay, now we can see that when we sort out our equation, it comes out as 16. So the radius is going to be 2, but we need to demonstrate all the steps. So fine. What we know is that, look, we know that circle with center in was such that x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. This implies we know that we're going to have to complete a square here. So we're going to have x squared plus 24x plus y squared minus 10y is equal to minus 153. We transpose the 153. And then what we do, we just take, so please, when they say calculate, no shortcuts, okay? 24x plus, we take that 24, we half it, so it's going to be 24 over 2. And then we square it, okay? Plus y squared minus 10y, we're going to add half of 10, and then we square it. Equals minus 153 plus 12 squared plus 5 squared. It's doing it. Okay, so the story that is told here is that we're going to add, okay, maybe let's just be as systematic as possible. So this is 24 over 2 squared plus minus 10 over 2 squared. Okay, that's what you do. And then finally, we take what is under the square root sign, we take the original sign, we take what is under that square. By the way, we should be writing a square there. The 2 got lost in the adjustment. So that is 12 squared plus y, we take the original sign minus, and then that one becomes 5 squared. Okay, all right, this one becomes 16 as we saw. So you see, when you've worked things out, you just transcribe in a smart way, but you want to make sure you show your work. So we can see that, okay, therefore the radius which is nt is going to be equal to the square root of 16, which is 4 units. Okay, not a problem. So here you just needed to complete the square. So essentially getting here and here is where the marks are. The rest of the gymnastics is applications of stuff that you already know. Okay, let's move on. That was 4.2.1. Ish, abonake. Okay, so that is the story, not a big deal. So we've got here 4.2. So we've got 4.2.2. It says now the length of TS. Okay, TS, maybe let's just highlight it instead. Now TS, if we're looking at TS, we can see that it is made up of NT. Okay, maybe let's write it on this side. NT, which we now just found out is 4 units. Okay, and this 5 units of the radius SM plus the entire length of NM. So all we can see here, we will say, for example, TS, we can just rush into it and say TS is going to be NM minus the sum of NT and SM. Okay, that is easy. Just say C diagram. They will see it too. But now we're going to play some serious gymnastics. NM is going to be the distance formula of, now here you don't need to be writing formulas, but maybe let's just do it. It's going to be x at m minus x at n squared plus y at m minus y at n squared, then minus these ones, nt plus sm. Okay, I did not want to do this, but let's just not take too many shortcuts. So x at m is minus 6, minus 12 is going to be plus 12 squared, plus y at m is minus 3, at n is 5, so it's going to be minus 3 minus 5. Then we substitute here. Well. Was there any point where we kind of, I think we need to be smart about some business here. NT, we just calculated above, is 4 plus SM is basically the square root. Let's just show that calculation. SM is the square root of 25. Because we never calculated it, so we need to be careful. Instead of just writing the answer, we need to show where we got it. Someone will understand. Some questions are just too much at times, so you don't want to overly do things. In fact, here you can even provide a reason that the circle center M, its radius, is half of that thingy that you've got. So let's just do the calculation without really wasting that much time. Minus 6 plus 12 squared plus minus 3 minus 5 squared. So minus the sum of 4 plus the square root of 25. So we're sorting things out. Yeah? So this one gives us just 1 unit. Okay. Strange stuff, yo. Sebenzela nje 1 xa untshwe madoda angeke. Ezinye izinto ziyamangaza kodwa nisele. All right, so my Coke is very nice. I like Coke these days, but it's gonna mess up my teeth. And I'm applying for that trouble. So now we've got 4 marks here. So we were a bit smart about our business. So essentially, this was an entire calculation for that substitution is a mark, okay? And then working out this 25, square root of 25, was already a calculation on its own, okay? And then we can simply say general substitution, and then the final answer, okay? So sometimes the marks can be smartly acquired without sweating too much. Let's move on. So for 4.3, all right, is saying determine. So now a determination, you know that in maths you can do it by inspection or by calculation or any other means necessary. You can write some statements like in Euclidean geometry and make some logical connection to those. All right. Determine the equation of the tangent, PR. All right. Now PR, we can see that it is that horizontal line. So here we need to speak about how to determine the coordinates of of R, because even though we did determine them, we need to put that into our argument. Fine. What we know is that since PR is parallel to the x-axis, okay, that was given, it is such that PR is perpendicular to MR. All right, what do we know here is that the radius is always perpendicular to tangent. Okay, not a problem. Now, what does that imply? This implies that x at R is going to be the same as x at M, okay? Why is that? This is a vertical line, okay? So, therefore, x at R is basically minus 6. Okay, so that is the first story. We can say, though, also, we know that y at R is going to be essentially y at M minus 5 units, okay? Because now we've determined that radius, okay? Minus 5 units. Or we can say minus MR if we will. Maybe let's just say MR just to be a bit systematic. I mean, this is nothing but distance formula, but only adjusted for a vertical line. We could easily have said MR is equal to that, and then we work it out. So y at M is minus 3 minus MR, which is just 5 units, which is 8 units. We can say, therefore, R is the point minus 6 is to 8 units. Okay, since this is a horizontal line, we know that, therefore, PR is such that y is equal to minus 8. Okay? Again, this is a horizontal line. Okay, easy stuff. So you don't want to overly cook that pot. It's going to start doing things to you. So what was key essentially was finding the coordinates of R, and then of course picking that minus 8. Maybe let's just write it properly here. Okay, now that is the story. The rest was just a means to an end, as we always say, guys. You cannot get a mark for an answer if your connections are not in the right positions. So we always work it out, okay? We always work it out. If you didn't want to say horizontal line, you can just say PR is parallel to the x-axis. Jonga ngisaphindi lapha yo. Okay, that's another version of this reason. So there's plenty of ways you can really attack this lion before it attacks you, but the marks are really scanty. So you just need to be a bit systematic about it. I do not see any other easier way than that. Anyway, we've sorted PR, 2 marks, but maybe a bit more, but they decided to be stingy. Now we want the equation of the line PS, okay? That PS, we already saw what we could do about PS. In the form y equals mx plus c, so basically it's a linear equation. So they decided to be generous. There's nothing special about that question, honestly speaking. Again, I always lose my focus now. Okay, guys, so you will forgive the man. So this is 4.3. Okay, then we've got 4.3.2. Now PS, we know that we start here by saying the gradient of PS multiplied by the gradient of MN is equal to -1, right? Right. Why is that? Okay, maybe let's start differently. We will know that PS is perpendicular to MN. Okay, again, here, what is that? Which we know is that the tangent is always perpendicular to a radius. Alright, so this implies that the gradient of PS multiplied by the gradient of MN must be -1. That's just the law, okay? It's the law. There's nothing you want to say about it. So the gradient of PS into, what is the gradient of MN? It's going to be y at n, which is 5, minus y at m, which is going to be minus 3 is going to be +3 over. Then y at n, x at n is -12. Plus 6 is equal to -1. From here, you can make a determination that the gradient of PS is going to be equal to, we just work it out. So let's see, this is basically 6. This is 8 over 6. So we've got -1 divided by, okay, let's just put it the way it is so that we avoid trouble. Sometimes it's easy to overlook certain things and end up where you don't want to be. So we don't want trouble. So this gives us a 3 over 4. Okay, so this is basically 3 over 4. Okay. Right. So that is essentially 6 over 8. Okay. All right. So now that we've got this little thingy there, what do we know? We know that this implies that line PS, okay, let's just say this implies that PS is such that y is equal to 3 over 4 x plus c. Now we know that through point K, which is -17, is to -5. We will have -5 is equal to 3 over 4 into -17 plus c. Therefore, c is going to be equal to -5 plus, now we've got 3 over 4 into 17 essentially. So that gives us a 31 over 4. Okay, great stuff. So we know that therefore our y is going to be equal to 3 over 4 plus 31 over 4. So scattered. Okay, so that is it, guys. So I don't know why it took 30 minutes doing this thing. Are you serious now? 30 minutes. One question ka. Anyway, so this thing had to come out because it was not indicated. If you don't do it, you are in a bad position. That is another thing that is important. Determining the C is important, and the equation is important. If there's anything I can tell you, is that this was a calculation on its own, so that is where the 5 marks come from. Okay, nothing really special. Again, 4.4, we're told quadrilateral P quadrilateral PSMR is drawn, so let's just do it. So PSMR. Okay, this quadrilateral is drawn. Great. So there it is. We can see it. Now it says calculate. Again, you can't just show up with an answer. We need to see a calculation. So calculate the perimeter. So once you say perimeter, it means just the length of that thing unfolded, okay, into a straight line. So now how do we plan this thing? So we realized that, look, this line PR is the same as the line PS because these are tangents from the same point outside the circle. And this, in effect, we already know that the radii of that circle is 5 units. So all we need is just PS. So once we determine PS, but PS will force us to work out the coordinate, the x-coordinated P. Without that coordinate, it is a little bit cold, don't you think? Yeah. So we will start our problem in this manner. So as you can see, it's 5 marks, so it's not really a walk in the park, but it's a bit of work. Now let's have a look here. What is the story there? The story that we want to tell is the fact that point P is essentially x is 2 minus 8. Okay, why is that? Yeah, it is like that, man. What can you say? I don't know, man, but yeah, we can just say PR is parallel to the x-axis. I don't know, it's a weak one. This suggests that the y, or maybe let's just do this. Let's start here. We're going to say y at P is equal to y at R. Now the story is because this is a horizontal line. PR is a horizontal line, né? Which is going to be equal to minus 8 because we determined it above. We can say therefore P is the point x is 2 minus 8. We're just trying to work out our business just right without rushing things. Now the next business that we want, we know that, however, PS is such that y is equal to 3 over 4x plus 31 over 4. Again, we determined that above. Then we can say through point P, which is x is 2 minus 8, it will be such that minus 8 is equal to 3 over 4x just remains x plus 31 over 4. Therefore, x is going to be equal to. Now, all we simply do here is going to say minus 8 minus 31 over 4. Okay? That we divide by 3 over 4. That gives us a minus 21. Yo. Injalo nalento. Hey, it can under 2 sanj. But if it is 17 already before that, so 20 minus 21 is appropriate. Okay, it makes sense. So we can say, therefore P, so we are transforming this is minus 21 is to minus 8. Okay, maybe let's put our conclusion side by side, this thing here. We can say, therefore, point P is minus 21 is to minus 8. So do you see, this is a determination of words. Okay, it's a calculation mixed with a determination. Okay, so what is the next business that we want? Easy now, because we know that we can say PR is equal to PS. Okay, maybe let's just say PS is equal to PR, because we want to use PR to our advantage. So we can say PS is equal to PR. But that is the story. What is this? These are the tangents from same point. Just forget anything else. These are tangents from the same point. But now PR is going to be your story there. This is going to be x at r minus x at... Actually, PR is a horizontal line, so we don't even need the distance formula here. So this is going to be x at r minus x at p, because it's a horizontal line. Yeah. X at r is minus 6 minus into minus 21. Okay, let's see, what is that? Minus 6 plus 21. It's 15 units. Okay, that is important. So yeah, that was a bit of a silly question, don't you think? Now that we have sorted our thing, we can say this then goes on to say the perimeter of PSMR is going to be equal to 2 times PR. Okay, maybe we can just use PS now because we determined PS, because that is the two sides that are equal, plus 2 times, say for example, MR, because those are the two radii. Okay, easy. So we've got 2 into 15 plus 2 into 5. Sorry, that is 30 plus 10, which is 40 units, right? So we've got 40 units. So that would be the perimeter. Perimeter is just the extended length of something that was folded or narrowed. So you can see here, it is quite a walk, okay? It's quite a walk. But what I can tell you is the 2 marks here is those 2 coordinates. Very important coordinates there. And then finding PR was very important. And then here we can simply say substitution and the answer. This is where the 5 marks come by. The rest was all a means to an end. It had to be logically connected. Okay, now let's go for it. Last question. Again, I keep doing this. So this is 4.4.1. Hey, Nkosi yami. Kodwa, do I really need to space this thing? I really don't. Kanje kukuphapha ngoku yabo. Sekukuphapha. The problem is that, guys, I don't want to teach you bad habits because I want you to know the right thing. Then you can just speed up knowing what to do. That is the job you have to do. I don't have to speed up. You have to. So if you have a complaint about my speed, sengxakini mntakaba. Kuwe wedwa uzaba nalo problem because mna anginayo lo ngxaki. I'm not doing this exam anymore. But I attempted though to show you things so that you speed up knowing what you're doing. Now this is a review, so we're supposed to indulge a little bit. Okay, let's not waste time. The area of triangle NPS. So where's triangle NPS? Maybe let's make it look nice. So there's N. Okay, N P S. Oh, is that one? And we can see there that if this is a straight line, we've got 90. Angles on a straight line is going to be 90. There's going to be 90 on the other side. So since we already know this side, we also know this side. Right. So we know that half base times height. So we're going to use the standard thingies for that triangle. But now we're saying here, over the area of the quadrilateral PSMR. But now how do we get the area of that quadrilateral? The best thing is to split it into two. If we split it into two like so, again, we know that side, we also know that side, and it's a right angle. So these are the same things. So these two are equal. So we just double the area of those triangles and then that one. So we sorted, so we don't need to sweat here. We're going to go for it. We're going to say, okay, area of triangle P, no, NPS over area of quad, no, of quad PSMR is going to be, that one is going to be half the base is going to be PS times the height, which is NS. Divide by, this one is going to be 2 times the area of that triangle. If we like, we can choose what to do here. We can take any one of those two. It's going to be PS if we choose PS so that everything is in order. Times the height is going to be MS. Okay, so this is pretty straightforward. So this is a half of PS we determined above is 15. And then that one, we saw that that radius was a 4. All of that shenanigan divide by 2 into a half multiplied by PS is 15 multiplied by MS, which is 5. Okay, so here you can just put it all in the calculator and, okay, maybe let's just simplify the top first. The top is going to be 15 by 2, that is 30, over. This one is going to be 15 by 5, basically. So which is 75. Now let's see, 30 divided by 75 is 2/5. Okay, that is the ratio, so we leave it at that. Nice and easy. So let's just see here. 0.5 into 15 into 4. I don't trust myself, Divide by 2 into 0.5 times 15 times 5. Yes, it's 2/5. Now that we are happy, we've got the marks here. It was just 2 marks. Wow. Are you for real, people? Okay, whatever. So that is how this question goes. And you can see this question is a bit silly. It is quite, you may look at these marks and see 22 marks is simple. But of course, maybe I'm taking too long to try and analyze things, just to give you a bit of, when you're actually answering this question, when you already know what to do, this one is much easier. Okay, I can tell you. You will always spare over some 30 minutes plus. Because what I'm saying now is what you would just do without explaining, and that saves you a bit of time. Okay, so that is it about question 2. Wow. Oh yeah, an answer sheet. This is the answer sheet. So let's get to question 5, which is trigonometry. Let's see if we can take this one down in just these little few minutes, just to take it to an hour. So question 5, it's more like algebra, right? So to prepare for the trigonometric section, here you need trig in general, linked to algebra, linked to triangle rules, linked to linked to what? Maybe we just stop here. Say here in trigonometry, you're just going to be dealing with this situation all the way. So trigonometry as a whole, bit of algebra there, then some triangle rules, they will help you. Now let's go. 5.1 says simplify without using a calculator the following expression into a single trigonometric ratio. Okay, let's copy it down. So we've got 1 minus sine of theta of minus theta times cos of 90 degrees plus theta divided by cos of theta minus 360 degrees. So this is all grade 11 work, okay? So again, mental preparation is that you cannot forget your grade 10. So first of all, what is the sign of a negative angle? It is negative because that is an angle in the 4th quadrant. So negative times negative is just going to be 1 plus sine theta. And then you sort this one out. Co-ratios 90 plus theta is the 2nd quadrant. Cos is negative there. So this is going to be minus sine theta. Okay. Then we come down here. Cos of 360 minus theta is the same as basically cos of theta. Okay. If you don't know what this is, you just factor out the negative. So it becomes 360 minus theta. Cos of a negative angle is positive, so it's going to be cos of 360 minus theta. 360 minus theta is an angle in the 4th quadrant, so cos is positive. Straightforward. Of course, I'm trying to save a bit of time because, there's nothing here. But if you think about what you are doing here, you're doing this guy. You're doing BOMDAS, applied BOMDAS. Let's just say applied, because it's not direct. Brackets off means reduction formulae. RF, reduction formulae. And then this one, this may talk about cancelling factors. And then addition and subtraction is basically like terms, as well as special angles. So you deal with this as you wish. Okay, and then of course this is reduction formulae as well as brackets off. So you deal with brackets and as well as reduction formulae. Here is just cancelling factors or just multiplication and division in general. Okay, easy, 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 easy. So that is what you do for an expression as simple as this. Okay, but you may need identities. So the other thing that you need to remember is identities. Okay, and then the other thing that you need to remember is factorizations of all kinds, from difference of two squares to trinomials and polynomials. Not a big deal. So you play around these little three things when you're dealing with trigonometric expressions. Now let's just do simple multiplication, which is just dm or md. This is the same as 1, and then now positive times negative is just going to be sine squared theta, all divided by cos theta. Now you can see that when we get to identities, this is the same as the square identity, so it's going to be cos squared theta divided by cos theta, which is the same as cos theta. So that's a single trigonometric identity. Then you can check this thing. How do you check it? You just assign any theta value. So just assign theta any value that is at the top of your mind or your lungs, whatever. Then you take this value of theta, you substitute into the original, you sort out. Then you take cos of that same angle. If those things are equal, then you know this thing is perfect. Okay? Don't walk away. These things can horrify you, as simple as they are. Let's get to 5.2. 5.2 says, okay, where are the 5 marks, by the way? First of all, the 5 marks is to do this thing here. 1, doing co-ratios there, and doing the sign situation right there. It's a mark. And then this one. So the first 3 marks is just all of those gymnastics. The 4th mark comes here when you use the square identity. That was a critical step, and the final answer, because we actually did not know. Okay, easy. Now let's get to this one. We are given that cos of 20 degrees is equal to P. Now always express it as a ratio. Now this already tells you and I that we're going to need our terminal arm diagram on the Cartesian plane. Now 20 is an acute angle, so already this is in the first quadrant. So this is the story that we've got here. So now this is going to be something like this. So that is 20 degrees. So cos of 20 is always adjacent over hypotenuse. So that should be 1. Okay. If that is the case, we know that x squared plus y squared is equal to r squared. That is basically Pythagoras. Okay, that tells us that. Therefore, we want to work out y. So x here is p squared plus y squared equals 1 squared. Therefore, we know that y is going to be the square root of 1 minus p squared. Okay, that is critical. Always do it before someone does it. You can even write it down here if you like, without even showing the calculation. Because I'm in grade 12 now, you're no longer in grade 11, so spoon feeding is not really expected. So it says without using a calculator. So if we can't use a calculator, we use our terminal arm diagram. All right, so let's do it. 5.2.1 says we need to solve cos of 200 degrees. What is cos of 200 degrees? Nice. 200 is in the third quadrant. Right. So this is 180 plus 20 degrees, right? So this is cos of 180 degrees plus 20 degrees. So you're going to use the power of reduction formulae, okay? But you need to show us first. Then cos in the third quadrant is negative minus cos of 20 degrees. This is going to be minus cos of 20 was p, right? Right. The answer is just minus p. Nice and easy. So I think here, the most important is this show right here. You know, that show was important because the rest is fine, but maybe not there. Maybe not there, but perhaps there, okay? Easy stuff. So this is 5.2.2. We're dealing with sine of minus 70 degrees. Now, what is sine of minus 70 degrees? How is that related to 20? Easy, bafwat. It's a negative angle. So that is in the fourth quadrant. Gross. So what do we do there? What do we do? You can already see there's just 2 marks. Now 70 is sine. This is the same as sine of so this is the same. Now to get that negative angle we need 20 because we want what we were given. So this is 20 degrees minus 90 degrees, right? Right. So now the strategy is that for those who don't know, you just say sine and then you factor out a negative. You're going to get 90 degrees minus 20 degrees. Now, sine of a negative angle is a negative sine of 90 degrees minus 20 degrees, okay? Now, sine of 90 minus is in the first quadrant. Sine is positive. Therefore, the co-ratio will be positive, but because of that negative on the outside, what is this thing? One is a balance into one. Anyway, that is the story right there. So 2 marks, I believe. The story that makes all the difference. This thing is technical, is it not? This is technical, so I suppose those last 2 ones should be, but the marks can be anyway. At this point, we really do not care. We just care for answering. Sine of 10 degrees. How do we get sine of 10? Oh, now we need to be smart. We can use our special angles here because we want to get 10 is the same as sine of 30 degrees minus 20 degrees, isn't it? Yes, because why should we suffer, man? Why? We don't need to suffer. So this is the same as sine of 30 degrees cos of 20 degrees. The sign never changes. Cos of 30 degrees sine of 20 degrees. So we needed identities here. So sine 30 is a half. We know from special angles. And then cos of 20, we know that it's p minus cos of 30 is root 3 over 2 into sine 20. Okay, now sine of 20 is this thing here. 1 minus p squared. Okay, That is the story. What we can actually sort out this thing to be like this. So it's going to be p minus root 3 times the square root of 1 minus p squared. If we simplify this a bit more, this is going to be the square root of 3 times 1 is just going to be 3 minus 3p squared all over 2. I don't think we can simplify any further than that. So the story basically was this expansion that was important, and then the substitutions and the answer. Okay. There will always be a question like this where you will need some sort of identities and their manipulation. But this is a very easy question, honestly. Take full marks there. There's no need to lose marks. If you lose marks, it means you're not a math student. You are bunking school when. So don't do yourself a favor. Attend class. So we've got cos of A plus 45 degrees. No? A plus, 55 degrees. Cos of A plus 10 degrees. Plus sine of A plus 55 degrees. Sine of A plus 10 degrees. Okay. Now we're told, without using a calculator, determine the value of. Okay. Now, if you look at this, you will see that there's this angle here, right? This is the first angle, or second angle. This is the first angle. And this thing keeps happening. A is like everywhere. Right? Right. Oh, no. What I'm doing is illegal. Look at this. This is the whole thing. This is a whole angle, and there it is again. And then we've got this second angle. Again, you can see. So cos, sine. What does that remind you? A cosine compound angle. So this is the same as the cos of the first angle is A plus 55 degrees. Now when the sine is like this story here, is our man. Once the sine is like that for the compound double angle, the sine is negative, and then we're going to have to put the next in brackets because it will hurt if we don't. So this is more like compressing an expanded cosine identity. Okay, all right, so this is the same as cos. Now we can see there that it's going to be A, taking out the A, and then 55 minus, actually 55 minus 10 is what, 45. And then cos of 45 is 1 over root 2. In grade 12, you never have to rationalize, but if you rationalize, you're going to get root 2 over 2, okay? So, but in grade 12, we don't really care for rationalizing the denominator. But in grade 11, you will never be allowed to leave things like that. You need to rationalize. So maybe if you rationalize, it's safer. But it doesn't matter, so the answer is like that. Okay. Easy. So this story here is important, and then coming down to that, and then the answer. That's how you get your 3 marks. So 5.4. 5.4 says, consider this lovely expression here. Again, you will always be given an identity to prove. So let's copy it down. It says now prove the identity. So what I'm going to do here, I'm just going to prove here the left hand side. Okay. So balance and you off and go cos 2x plus sine 2x. But don't cut corners like I am trying to now. Your job is to be diligent. Ningabi ngoxathavana nje bonqenayo. Naqala nonqena ngoku ngizoba useless. Nginiyazi loo nto le. You can do all the shortcuts you want. If you're lazy, you're gonna be useless in the future. Believe me. There's a lot of people who are surprised by that reality. Okay, I'm probably one of them anyway. It's fine. Now let's see. What do? Now we think about our business here. First of all, we need our BOMDAS or BODMAS, okay? Basically, in its true sense, which is the order of operations in arithmetic, as well as applied to trigonometry. That's number one. Number two, we need factorizations. Right? Great. Number three, we need identities. So these are the little things that we can use to solve issues like this. First of all, what do we see? On the numerator, we really don't have like terms, do we? We don't have brackets. We have nothing that can say step number one is going to help us. So the next step is to say, can we factorize that thing? The answer is not necessarily. It's not in the form that we can factorize. Number three, can we use trig identities? Yes, most definitely, because this is a double angle. Oh yeah, these are double angles. These are double angles. So we can start there and say, fine. Now, we need to be smart about our business. We don't rush to change everything so that it disappears altogether. But what we know is that we can attempt to change this. Okay, let's just see. I'm not too sure what I'm going to do here. But what I'm going to change here, because of this guy, I'm going to change cos 2s to cos squared x minus sine squared x. So you know that is the story. And then we're going to say plus. This one is 2 sine x cos x. And then minus cos squared x. Okay. And then here, we really don't have much that we can do at the bottom, can we? Yeah, we don't have stuff here. So we're going to have sine x minus 2 cos x. Okay, that's all right. So what is the next step? The next step is, now we know that these two dudes will essentially do it. So that's why we wanted to get to that root. So what we have left is essentially, we just rearrange this thing. We're going to get 2 sine x cos x and then minus sine squared x. Because ingathi ndiyazixhoma bantwana basekhaya ethi ndingazixhomi. Let's leave it the way it is, minus sine squared x plus 2 sine x cos x. So sometimes contain your excitement before you apply yourself a situation. Now, once we are here, because look, what did we do? To break this into what we've got here, we used trig identities. We had no choice. We started there. Then the next thing, we used BODMAS to handle like terms, that cos squared x minus cos squared x. The next step is to factorize that numerator. But the manner in which we factorize here, we're going to take the lowest common factor here because if we take the highest common factor, we're going to run into problems. Actually, we need the highest common factor technically, which is basically sine. Now let's be smart about the business here. We want this thing to remain like the denominator, so we're going to take minus sine x. Now all that remains inside is going to be sine x, now minus 2 cos x over sine x minus 2 cos x. And guess what? These two finally do the number to each other, and the remainder is minus sine x, which is equal to the right hand side. Although I did not show it, I'm sorry guys, I just could not do it any longer. Now do you see? Look at this procedure. First of all, we inspected if we could use BODMAS. We realized we could not. The next thing that we could see we would do is the trig identities, which led us to step. This led us to step number 2. Now in step number 2, we got the AS portion of our BOMDAS. Let's do it. Like terms. We handled like terms. So do you see, we are almost always running around these three things. That is sorry guys, that's a problem. It's a bit tired now. The guy is a bit fried. And then, which led us to the third step. The third step is when we actually simplified by sorting up those things, those like terms. Now in this step, we were drawn to factorization. Factorization either by highest common factor, doing a trinomial or a polynomial, or difference of two squares. And that's exactly what we did here. So once we got that, we came back to the DM section, where like now we've got factors to cancel. So we've done our DM, okay? And that situation essentially gave us the answer. Okay, so if you follow this procedure, I promise you, when you practice these things, following this procedure, these things are never going to be a problem for you, ever. But if you don't, you think you're going to cut the corners, you're just not going to know everything. Sometimes you don't even know where you're going. You just keep testing the waters. So do not think you're just going to, imagine things working here. Akuvele nje uJoje apha. Ndim ndodwa igqirha. Ke nna fela ngaka mona. Ke nna fela kgonang ho bona ntwe. Wena ha o no e bona. Jwale ke a o bontsha tsela tsa ho ihlalosetsa ntwena hantle fela. Hore be bonolo tlo kgona ho tsamaya hantle monna ka mahlohonolo, wa bona. Jwale ha o sa batle he dintho tse mpe, o tlo etsa ntho e right, o tlo practice. Hantle ntle ke entse di-video tse ngata ho YouTube mona. Ha o ka subscriber fela, ke a o tshepisa o tlo di bona kaofela. Ha o sa di bone, ke a o jwetsa le wena o tlo bona hantle hore ntho tsena kaofela di bonolo. Ho na le tseo he tse leng thatanyana. O tla tshwanela hore le wena he ha ntso ikotlisa mona, o iketsetse hore mona o be matla, o tlo kgona ho emella, wa bona. Hobaneng ho tlo tlatse dingwe dintho, di-tornado mona di tlo sorta out. Anyway, xelele yonke into ofanele uyazi, sengikutshele konke usufanele ukwazi hike manje. I've told you everything that you need to know. The thing is for you to do the things that must be done by you, which is practice, practice, practice. My channel is here, Bafweto. It will give you a lot of insight, believe me. I do not do answers only. I don't reproduce memorandums. I am not interested in doing that. All I want you to know is how to use your methodical approach, a systematic approach, using your knowledge adding a bit of logic in there. All the spices that make the things nice, isn't it? Because at the end of the day, is an edible, answering technique that is on point with all the right things, because you want to build your logic now. When you get to medical school, if you're going to choose medicine, they will tell you that you need a systematic approach. You cannot examine someone by starting by touching them. If they say my arm is painful and then you start touching the arm, and I'm like, oh, it's painful when I move it. Okay. And then you remember, oh, I forgot to measure the blood pressure. And then you start measuring the blood pressure. And then the next thing, like, oh, I forgot to take the history. What happened? Did you fall? Did somebody beat you? Did you lie on the wrong side? What? And then the next thing you're like, I forgot again to introduce myself. I'm Dr. So-and-so. You see, you can't do those things. You will fail terribly in medicine or in medical school if you don't have a systematic approach. So you might as well learn it now, okay? Because when you get there, even if you don't follow exactly what may be outlined in your whatever guidelines or manuals, we used to call them manuals, or whatever it is that you are given, a pamphlet that says this is how you do things. But if you do things in a methodical way that helps you to get to the diagnosis, which is the answer in this case, is the way to go about it. Anyway, let's not talk nonsense, guys. I'm almost done. This is why I'm trying to relax. Now it says determine the value of this thing here. It's 3 marks. Okay. Now there's a very good chance that this shenanigan is linked to that shenanigan we just did, because all you can see here is that the numerator, the numerator is the same as that numerator. So that shenanigan is linked to that somehow. So we need to remember what we just did over there. Okay. So there's always clues. I don't know, guys. If anendiva nangoku ayindincamile mina. Ndiyanincama ndihlamba izandla zam ndithi Nkosi yam ndibazamile abantwana. Kodwa abeva abayiboni le nto. So let's start. Cos 2x plus sine 2x minus cos squared x divide by minus 3 sine squared x plus 6 sine x cos x. Okay, now the only different business here is the denominator. We're like, denominator, you are the one that looks different from what we just did above. So it means it should be your focus at the point in time. So we leave this 2x plus 5 sine 2x minus cos squared x. So we just leave the numerator alone. Here you're just playing strategic. This is a high order question, by the way. It's like NBT type of questions. You see, in NBT you'll be asked questions that seek logic now, more than just a direct question like that of simplify or at least proving something. Here you need to be smart. You play the game now here. This is when you gamble. Go to the casino, take some chances there. But now what do you see on that denominator, guys? In the denominator we've got sine of x. That is common. But not just sine of x, but 3 sine x. Okay? 3 sine x is common to both bafowethu. Ngiyantshela ke manje uba anilaleli uzoshimpama la. Sesibheke nje la kulo minus 3 sine x ukhona macala, because la 6 can be split into 3 times 2. So ukhona 3 sine x. So which means we're going to factorize this bagara. Oh, Nkosi yami, what did I do now? You. Ngenza izinto ezirongo wena. Ish. Khona into engekho right ke apha yenzekile. And ke ngoku izondisokolisa because yabona kwenzeka le nto ngoku. Hey! Banna we. Casual. Ish. Look at this dude. Yare doch. Sinengxaki ke ngoku. Sekwenzeke le nto ingafanelanga ba yenzekile. Yes. Ah, Lord. Andazi ke ngoku kwenzeke ntoni apha. Suka wena man. Yho, nantsi ingxaki ndehlela yini nabawo. Yes. Ish. I don't know what happened, guys. Yo. Hayibo. Hayi ke ngoku. Angisazi. Hayibo nkosi yami, yintoni ngoku? Yintoni ngoku le yenzeka apha? Ay. Yabafethu ithiwani ke ngoku le nto ke. Okay guys, I kind of sorted the problem. I shouldn't be too excited. In any case, so we know that if we factor out, say, we want minus 3 sine x. On the bracket, what we are left with is essentially, my tablet is losing its power. So it's minus. So if we take the minus out, what remains is sine x. Now that one becomes minus. This one becomes 2. No, sine x is out. So all we're left with is cos, 2 cos x, is it not? So factorizing by taking the highest common factor, actually, not the lowest common factor. And now what do you see? This denominator right here looks something like that denominator right there, is it not? So now we've got what we wanted. Now we need to be smart about our business. So if we factor out 1 over 3 sine x, what do we end up with? We end up with cos 2x plus sine 2x minus cos squared x all over sine x minus 2 cos x, okay? Maybe we don't even need a big bracket here. We just put this one like that. Because remember, when we cannot cancel things out, the numerator multiplies the numerator, the denominator multiplies the denominator. It gives us exactly what we've got. But now from above, we're told this is now minus 3 sine x into this bracket is effectively minus sine x from above. And then this guy is out. So this becomes just a third. Okay. So that is the story. That is the story that you must watch out for. So here it's a bit of strategy than anything else, but you will see that we follow the same procedure. Okay. Easy stuff. So the 3 marks here is essentially this factorization and this situation right here and the final answer. Easy. Okay, let's do the last question without wasting time. 5.5, we are given 3 tan 4x is equal to minus 2 cos 4x. Okay, now we are told here 5.1.1 without using a calculator. Show that this sine 4x is equal to minus 0,5 is the only solution to the above equation. Okay, let us do it. So we've got here okay, what do we do with a situation like this? We always use the tan identity. It's going to be 3 into sine 4x over cos 4x, okay, equals minus 2 cos 4x over 1. Then the gymnastics of algebra or arithmetic. So if we cross multiply there, we get 3 sine 4x is equal to minus 2 cos squared 4x. Okay, all right, okay. Now let's see what we can do here. Now we need to play it smart here. We're going to use our identities here, trig identities, because now we want to make this thing to look like sine 4x. Can we? Yes, we can. So we've got 3 sine 4x is equal to minus 2 into cos squared 4x is the same as 1 minus sine squared 4x from double angle identities from grade 11. But the only smart thing is that we're using 4x instead of, just any x. Remember, that is the story. And then we simplify. 3 sine 4x is equal to minus 2 plus 2 sine squared 4x. Yeah, and then we transpose everything to one side so that we can have our trinomial. We've got 2 sine squared 4x minus 3 sine 4x minus 2 equal to 0. I've just rearranged, nothing major there. So we can do our final factorization, grade 10 style. So this should be 2 sine x, this one should be sine x. Now factors of 2 that can give us a 3 is if we say we're taking our 2 and put it here, but it must be a plus 2. Okay, no, a minus 2. Because we want to say 2 by 2 is 4, then we put a plus 1 here. So minus 4 plus 1 is minus 3. So we've sorted our trinomial. And then what do? We can say therefore sine x is equal to minus a half when you equate that bracket to 0, or sine x is equal to 2, which will never, remember, sine of any angle cannot be more than 1. It only goes to 1. When sine does not have a double in whatever multiples, it can never be 2. So these guys are really silly, This is the solution. Okay, you can even try there. Say sine of, just say, look for that angle. Arc sine of 2 is undefined, because sine of any angle must be between 1 and minus 1, because that's the maxima and minima, because this is not shifted or multiplied. But if you start putting a coefficient, then perhaps we can start talking. But now we can't talk, okay? Yeah, we cannot talk because there's no multiple there. So that is the story. So essentially these guys are just saying, show that sine 4x is equal to, oh, look at this dude. Overexcitement, my angle is wrong. You see, you do the right thing and then the next thing, something stupid happens. So if you don't watch yourself, you're gonna be in trouble. Okay, that's it, guys. We did it. Again, what did we have to do here? We saw that we did not have any common factors whatsoever. So we needed to use identities to get to this stage, right? From identities, we were able to do multiplication and division, which is that cross multiplication there. It landed us there. Again, we saw that, fine, we still needed identities to sort this one out. Right. And then from there, what did we do? We just simplified. And after we simplified, this stage is important, of factorizations. So we've got 3 marks there. And then here, essentially, I suppose this one was already gifted. So rejecting that one is where the extra mark comes from. Okay, let's do the last question, because I'm feeling a bit dizzy. I feel like I'm gonna fall. I need to eat something. Anyway, It's so late. It's like 3 a.m. in the morning. Yeah, this guy is dangerous. Why am I doing these things in the morning and I am hungry? Yeah, there's a stool. Anyway, that is the story that we must just have to deal with. I don't know why it took long here. But let's just move, guys. Hence, determine the general solution of x in the equation. So since we know that equation, so we know that for this equation, we know that the only solution is sine of 4x, sorry. Yabona ke iphindekile le business. Hayi wena man, sunhlanyisa wena man. So sine of an angle cannot be greater than 1. So that one is the only correct one. Yes. And then now we know that sine of 4x is minus a half. Okay, great. This implies that 4x is basically arc sine of minus a half. Okay, plus k times 360 degrees, which is the period of sine, right? Or 4x is going to be, for sine you always consider this. This is where k is an element of integers. Okay, alright, okay. Now we sort out 4x is equal to shift sine of a negative half, shift sine of minus 0.5 is minus 30. Okay, I should have thought about it. Why didn't I? Hey, when Skatroba slow mona. Plus k times 360 degrees, or 4x is going to be equal to, now it's going to be 180 degrees minus into minus 30 degrees, right? Plus k times 360 degrees, where k is an element of integers. Now, what do? We therefore make a conclusion that x is equal to, now we're going to say here, minus 30 by 4, oops, is minus 7.5 degrees. Yeah, that's what it says. Okay, plus 360 by 4 is 90, right? So it's going to be k times 90 degrees. Or x is going to be here, let's say 180 plus 30 is 210, divided by 4 is 52.5 degrees, plus k times 90 degrees. So that is the general solution of x in that situation. Oh yes, k, this answer is incomplete if you don't say k is an element of the z, the integers. Okay, so you're getting a mark for each one of those two general solutions. And then what is the next story? The next story, yeah, the 3 marks are strange, Icon. Ujesu wasemandulo isesenguye namhlanje. So we'll make these ones 2, so it's going to be a half and a half, okay? Now that is it, guys. That is it, because we've answered question 6. So we've done it, and we've done this paper. So this is the end of this little video. Although it took a bit of time, I did not plan for it to take this long, but yeah, it took long. You like it, you don't like it, I have no control of the situation. Bye-bye.